Okay. Thank you all for coming today. This is the Natural Language Processing in Python by our speaker, Alice Zhao. She's a senior data scientist at Metis, and I believe that she has a bit of a tutorial that we can follow along with. So please join me in welcoming her.
All right, thanks everyone. It's so great to see a full house here today. I'm very excited to speak at the PyOhio conference. One of my colleagues spoke here last year and he loved it, and so he recommended that I come as well. So today I'll be talking about natural language processing in Python. And the first thing I want to mention is this is a 2-hour-long tutorial. So I'm just making sure that everyone signed up for sitting here for the next 2 hours. Also, I'm going to be walking through a couple of Jupyter Notebooks. So Jupyter Notebooks are this nice way of doing Python code, and we use it a lot when we teach our data science boot camps. So if you go to github.com/a-of-data, there's a README file up there as well that has some setup instructions. So that includes downloading Anaconda, which is how we recommend our students use Python, because it comes along with a lot of data science packages as well. So I recommend you download that. And then once you download that, you can try to see if you can open up some of the notebooks. So we won't be touching the notebooks for about 20-30 minutes. So over the next 20-30 minutes, try to get that set up, and then I'll check in with you again to see if you have any issues. All right. Also today, we're going to be walking through an end-to-end project. So I see a lot of tutorials out there that are algorithm specific. So they'll be like, okay, we're going to teach you this algorithm or this algorithm, but it's hard to see how it all comes together. So my goal for you guys today is to show you how to start with a question and then go through all the steps of cleaning the data and doing some exploratory analysis and then applying the algorithm so you can see how an end-to-end project works. Okay, so here's the schedule for today. So first, I'm going to give you an introduction to NLP and then also data science, because I'm a data scientist, so I'm going to show you how I approach problems. And then we're going to go into the tutorial, which is going to be in the Jupyter Notebooks, and then I'll end with a conclusion. So let's start with natural language processing. So all of you signed up for this tutorial. Do you know what NLP is? Can I hear any suggestions? I see some nods, yeah? Yeah, I love that, finding meaningful information from random text. So when I think of natural language processing, I think of it in two parts. So the first part is a natural language. So what is a natural language? Well, when you think languages, you see all these languages up here. Which one of these is not like the other? Python. So Python here is not a natural language. So Python was written for coding, whereas natural languages are languages that have naturally evolved over time that humans actually use to communicate. And then processing, I think of like a processor on a computer. So it's how a computer carries out instructions. And so natural language processing is how a computer is able to process these natural languages. And then more simply put, just like you said earlier, I think of natural language processing as just simply how to deal with text data. So today we're going to be working with text data. And then the other thing I want to point out is that NLP falls under the greater branch of artificial intelligence. And I want to mention this because AI is such a hot term these days. And AI is all about a computer performing tasks that a human can do. So that includes things like image processing, right? Humans can see, so how do you make a computer see? Well, in this case, since we're dealing with language, humans can interpret language, so how can we make a machine interpret language? Okay, so now I'm going to go through a couple examples of NLP. So let's say that you're the manager for a customer service center. So you are working for a company, and you sell hats, and you also sell shirts. And then you get a bunch of calls from people that talk about like them loving your hats or them hating your shirts. And you want to get an idea of how people are feeling about your hats and shirts overall. So let's say you have 1,000 calls. If you're the manager, you could go and listen to all those 1,000 calls, but that would take a very long time. You might have your customer care reps maybe take notes on who's happy about what. But another thing you can do is you can use NLP techniques to actually read that text and figure out, is this a positive emotion or is this a negative emotion? So by applying NLP, you can see that people are generally pretty happy about your hats, but they're not really happy about your shirts. So this idea is called sentiment analysis, and this is one of the things that we'll be going through today. Okay, so another example. So say you're working at a legal firm, and you're working on a case where someone at a company may have embezzled some money. And so you need to figure out who is doing all the bad things at the company. And so you go through all the emails at the company, but then you realize there's like 10,000 emails that you have to go through. So how do you prioritize which emails are likely related to embezzling money versus something random? And so what you can do is you can look at all your emails, and then you can label them. Not you manually labeling them, but you can have a machine use an NLP technique to label them and say, okay, these emails up here are about project work. I see these are about money. This one's about someone's honeymoon. It's very personal. So this is probably a low priority email that you don't need to read. But then maybe the ones about money are the ones that you should make higher priority and read first out of the whole 10,000 email set. So this idea here is a very powerful NLP technique called topic modeling. And I find this very, very interesting. And this is one of the ones we'll be talking about today as well. And then finally, this is a kind of fun example, but say that you're a writer and you work for an inspirational quote company. And you have been tasked to write inspirational quotes for 365 days of the year. And you've written it for 11 months, but you're just completely out of ideas. And so you're thinking, okay, I have all these inspirational quotes. I'm a Python developer. Why don't I just code something up that will write inspirational quotes for me based on my past quotes? So you can do just that with something called text generation, which is the final thing that we'll be talking about today. So just to recap, the 3 NLP examples we'll be going through today are sentiment analysis, topic modeling, and text generation. So these are just some of the NLP techniques out there, but they're ones that I find very interesting and also a good introduction to data science. And so before we go through all these techniques, we're actually going to go through a lot of data cleaning. So a lot of people think, okay, these are such cool techniques, let's use them right away. But there's a lot of steps we have to do beforehand, which I'll be walking you through. So that's natural language processing. What is it again? Yeah, out of language, out of text data. Okay, so that's NLP. All right, so now I want to talk about data science. And I'm very passionate about data science because I'm a data scientist. And I like to give a little intro about this because this is how I see these problems. So has anyone here heard of data science? Okay, what is data science? Exactly, I love that, getting meaning out of data. Or using, I wrote here, using data to make decisions. So it falls under analytics, which is generally using data to make decisions or getting meaning out of data. But under analytics, there's other things like business intelligence, which is like creating dashboards. And then there's data science. So when I think data science, I always think the data science Venn diagram. So this was created by Drew Conway, a data scientist, about 10 years ago. And I always have this at the beginning of my lectures. So what he says is that every data scientist should have 3 types of skills: programming skills, math skills, and communication skills. So if you have all 3, you're a data scientist. So let's say you have 2 of the 3. Let's say you have programming and math skills, but no communication skills. So then you're more of a machine learning engineer because you can code, you know all the algorithms, but you don't necessarily have to create presentations, right? On this side, if you have math skills and communication skills, you're probably more of a researcher. So you don't have to deal with a lot of data, but you know the algorithms, you have the domain expertise, and you can do great research. So over here, this is the danger zone. And I want to mention this because I've seen a lot of people fall into this danger zone. So these are people who know how to code, like everyone in this room, and also have communication skills, so like know how to communicate ideas. And so if you have these 2 skills without the math skills, then you fall into the danger zone because what ends up happening is you'll just pull packages or libraries out there, use them, and not know how to interpret the results or interpret them incorrectly. So because of that, today we're going to be going over all 3 of these types of skills. So first, we're going to be talking about a couple different Python libraries. So for data analysis, my favorite is pandas. So we'll be talking about pandas. We're also going to be talking a little bit about regular expressions. Has anyone heard regular expressions before? So powerful, right? It's great for text data. And then also scikit-learn, which is used a lot in data science. And it's a great way to, has a lot of machine learning tools available, but we're going to be using it to format some of our data. We're going to be using a couple NLP libraries. So the most popular one by far is NLTK, Natural Language Toolkit. And then TextBlob is built on top of NLTK. And then gensim is specifically used for topic modeling. And don't worry about knowing all this right away. We're going to walk through all this today. And so that's from the Python side. From the math and stats side, this is where I really want you guys to try to understand these concepts, because it's so important in interpreting the results. So we're going to be cleaning the data, and we're going to be putting it into a couple formats. So first is just a general corpus format, which we'll go over in detail, and then also a document TermMatrix. And then we're going to do some exploratory data analysis, which I'll be calling EDA from now on. And that's going to be a lot of word counts. And then finally, we're going to be going through those three techniques that I mentioned earlier. So sentiment analysis, topic modeling, and text generation. And then finally, there's this communication piece. And usually all the soft skills kind of get lumped into this area. But I think of it as two parts. So there's a design piece, which is all about how you design a project. And this is so important. Whenever I advise my students, I find that this is where they struggle the most. So just figuring out, if you have a question, like where to start, how do you scope out your project, what insights can you draw from that data, what visualizations can you make to communicate things more effectively. So that's all about design, and we're going to be doing that throughout the tutorial. And then finally, having some type of domain expertise is really important. So I'll be sharing with you the project we're going to be working on throughout today, or the question we're going to be answering, and hopefully you'll know a little bit about the subject area that you can help me interpret the insights. Okay, so before we move into the tutorial, the last thing I want to talk about is the data science workflow. So the data science workflow, this is the order of steps that we usually take to solve a problem. And this is the order that we're going to be following today. So the first is to start with a question. So a lot of people think, well, data science, that has data in the title, so you have to start with the data. But that's not the case. You should always start with a question in mind, because that will influence what data you're actually going to collect. The first step is to start with a question. Then you're going to get the data, perform EDA, which stands for exploratory data analysis, great. Then you're going to apply some NLP techniques, and finally share all those insights. So let's walk through a simple example. So let's say I had the question, if I study more, will I get a higher grade? What are your initial thoughts? Yeah, hopefully, right? So that's your guess. But then within the data science workflow, the next thing you're going to do is you're going to get some data. So what type of data might you get? Number of hours studied, grades. Perfect. Yeah, let's start there. So let's say I go and I talk to a teacher, and I get this information. So for all these students, this is the number of hours they studied. This is the grade they got. So take a look at this data. What do you think of it?
It's not consistent.
What's not consistent about it?
Well, you've got numericals and you've got strings.
Yeah, there's definitely bad things happening here, right? We see a 2 here. We see someone might have had a typo here. And so at this point, I need to clean the data. So this is what we mean by clean the data, to get it all in a consistent format. So at this point, you're going to have to make a few assumptions. So I'm going to assume that that 2 means a 2, and that 908 was actually 98. It might not be always correct, but I think it's a pretty good assumption to make at this point. OK, great. So I've cleaned the data. So the next thing I want to do is perform EDA. So what this means is I want to quickly understand, quickly see if my data makes sense. So this is typically done through visualization techniques. So knowing that, what would you do at this point with this data? Yeah, scatter plot, perfect. I'd create a scatter plot. So just by looking at the scatter plot, what are some things you can learn from this data? So this is. Yeah, great. We see a positive correlation, right? you see that the more hours you study, the higher grade you're going to get. Anything else?
Some people are really lucky. The ones who study less than 5 hours.
Yeah, they did. Yeah, they did pretty decent. The other thing that I found here was this person up here. That was Charlie. He did pretty well without studying that much, right? So those are my two findings. That's what you'll typically see with numerical data. First, you want to see if there's any correlation, and then you want to see if there are any outliers. So in that case, that's an outlier. Great. So that's my EDA. My data makes sense, right? The more I study, higher grade I get. Great. So only after you've done your EDA, now it's time to apply some techniques. So the most basic data science technique is applying a linear regression, so fitting a line to our model. And you can see here that with a linear regression, I can actually get a specific equation to see what that relationship is. And so at the very end, now I can share all the insights, basically summarize everything I've done. So my question was, if I study more, will I get a higher grade? And the answer is yes, there's a positive correlation. And then specifically with linear regression, we saw that this is the relationship. And finally, we know that Charlie was really smart, and then he was kind of an outlier. So at the end of the day, even if linear regression predicts you're going to get an 80, you're probably going to get slightly less because of that. So that right there was our whole data science workflow. Make sense? Great. OK, so at this point for this section, I talked about data science being part of analytics. And it's all about using data to make decisions. Talked about the Venn diagram and not to fall in the danger zone, because you need to know the math. And then finally, the workflow. All right, so let's get into the tutorial, which is what you've all come for. So was everyone able to open up a Jupyter Notebook? Does anyone have issues? That's pretty amazing. Nice job, guys. That's amazing. OK, great. So at this point, we are going to go through all of these steps. So the first thing we're going to do is I want to note that for the get and clean data step, the only difference with NLP analysis is that this step is going to be using text data. And this is going to be the format for today. So I'm going to have a presentation at the beginning of every section. And then you see here, there are 5 notebooks for you to follow along with. And so I'll be doing a notebook after these middle 3 steps here. OK, so the first step is defining a question. So this is the question that we're going to be focusing on today. Does anyone recognize this woman? Anyone? She's a comedian. OK, so her name is Ali Wong. And about 2 years ago, I was not into stand-up comedy at all. And I saw her special on Netflix, and I really liked it. And I was kind of surprised, because I'm not into stand-up comedy. And then at the time, I was thinking, OK, do I like her because she's also female and Asian, and I was also pregnant at the time? I'm thinking, maybe, but maybe there's something more to it. Maybe there's something actually in the language that she's using that makes her different from other comedians. And so that's the question that we're going to focus on today. OK? So our goal is to see what makes Ali Wong's comedy routine stand out. Does that sound good? OK, great. All right, so now we've got our question. Great. So the next step is we have to get our data. So there's 2 parts to this. We have to get our data somehow, and then we also have to clean that data. So the input into this step is, OK, how is Ali Wong different from other comedians? And the output to this step is we want clean, organized data that looks something like this, because this is what a machine can work with. OK, so for this first step, data gathering, my question to you guys is, how are we going to get this data?
We already got it in the GitHub repo.
You have it in the GitHub repo, but how did I get it? How did I get this data? Transcripts. So luckily, when I was thinking of doing this project, I just Googled Ali Wong Baby Cobra transcript, and then it came up. So very, very lucky there. And then the second question is, how much data are you going to get? So I said I wanted to compare Ali Wong with other comedians. So how would you decide how many comedians to compare her to?
Just take the top 10 comedians.
So who are the top 10 comedians? How would you define that? So I actually did exactly that. I Googled who are the top 10 comedians, and every list was different, right? So how are you going to?
And find which lists have overlaps.
Yeah, that's actually a great idea. So you could do that. So I tried to make this as much of a data-centered approach as possible. So the way I did this was, okay, first, this is where I got the transcripts from. And then second, I went to IMDb. Because IMDb has this advanced search option. And I tried to adjust the filters so that I would get about 10 comedians. And it would include Ali Wong. And I think those are my two requirements. I would get about 10 comedians, and it would include Ali Wong. And so I ended up kind of tweaking the features, tweaking the filters to make this make sense. So at this point, I just want to pause, because these questions that I've asked you seem really simple. They're very hard. And this is always where you have to start your analysis, is thinking, like, how do I want to scope my project? And this is where your domain expertise matters a lot, because I'm going to get this list of top 10 comedians, but I also have to make sure that my list makes sense. Like, I don't know too much about stand-up comedy, but my husband knows a lot about stand-up comedy. And so I asked him, and he's like, OK, this list makes sense. You can start here. So the way I decided to limit my scope was I looked at comedy specials from the last 5 years. They had to have at least a 7.5 rating out of 10 on IMDb with over 2,000 votes. And then I ended up with about 20 comedians, and then some of them showed up multiple times. So I had to figure out how to deal with that. So then I decided I'm just going to take, for every comedian, their top-rated special. And that's a good place to start. So these are the comedians that I ended up with. So is anyone here into stand-up comedy? OK, so looking at this set, is this a pretty representative set? So like the ones I recognize here, there's Ali Wong. And then I know Dave Chappelle is popular. I know Louis C.K. is famous. I don't know many of the others, but having a few in there makes me feel good about my data set. So great, I've locked in my scope. Let's move to data cleaning. OK, well, actually, before we move into data cleaning, I just wanted to mention a few of the Python packages that I've used here. And we're going to walk through this more in the notebook. But throughout my presentation, anything that you see in teal, that's going to be a Python package. So for web scraping, has anyone done any web scraping here before? OK, so then you'll recognize these. So I use requests. So request basically allows you to enter in a URL, and then you can get all the data from that URL. And then beautiful soup is great, too, because then it actually looks at that HTML page, and then you can pick out certain sections from that HTML page. So just think of a web page that has transcripts on it, but it also has a ton of other stuff. With request and beautiful soup, you can just pull out the transcript text. So that's the web scraping side. And then also, I did a lot of pickling. So you'll see I created 5 different notebooks here. What I do is at the end of every notebook, I'll pickle some objects. And what that means is I can save the object for later. So think of an object like a list. You can pickle a list so that you save it, and then in the next notebook, you can load it up and read it and use it again. So you'll see a lot of pickling throughout. OK, so we've gathered our data. We have 12 comedians. Now we have to clean that data. So our goal for this step is to get the data in a clean, standard format that we can use for further analysis. And we're going to get our data in 2 types of formats. The first is just a general corpus, which we'll talk about in a bit. And the second that involves a little bit more work is a document TermMatrix. So the first is a corpus. And a corpus is just a collection of text, very simply. So the goal for this step is just to get the data in this nice table here. And the way we're going to do this is using pandas. So again, pandas is the Python library for data analysis. And specifically in pandas, there's an object called a DataFrame. So a DataFrame is essentially just a table. It looks like this. So every row of a DataFrame will have an ID. And then every column of the DataFrame has the same data type. So we're going to be creating a pandas DataFrame to create this corpus for us. So that's the first format, very easy. So the second thing we're going to create is a document term matrix. And this is a little bit more complex. So the things we need to do here is first we have to clean our text, then we have to tokenize it, and then finally put it into matrix form. So let's walk through this step by step. So this is the first line of John Mulaney's stand-up routine. And if you look at it, it looks pretty messy. So if you were a computer and you wanted to only understand the most important parts of this line right here, what would you do to make this data cleaner?
Get rid of the punctuation.
Great idea. Get rid of punctuation. Any other ideas?
Helping verb,
What's that?
helping verb like will, on, prepositions and
Mm-hmm.
verbs.
Yeah.
Change the date to the actual date format.
Yeah, these are all great ideas. And these are all things that you can do to this text. So there are many different ways that you can clean your text, but there are a couple of standard ones that we're going to be going through. So the ones that we're going to be doing today is first removing punctuation, also making everything lowercase. And a very common thing to do is to remove numbers and any words that have numbers in them. All the things you guys said can be done, but this is just like a very quick first pass. So if you did all of those things, then your text would look something like this. So at this point, we've done a first round of cleaning the text. So everything's lowercase, and we have them in mostly a standard format. So the way we're going to do this is using regular expressions in Python. So regular expressions are very powerful. If you think of like Control-Find on your computer where you can search for one word, with regular expressions, you can search for patterns. So you can search for anytime a word starts with a capital letter, do something with it. That's the power of regular expressions. I'll walk you through that later as well. And so now that we've cleaned the data, the next step is to tokenize the data. And tokenization is a very standard term in NLP. So to tokenize something means to break it down into smaller parts. So you can tokenize things by sentence. You can tokenize things by two-word combinations. They're called bigrams. But the most common way to tokenize is by word. So at this point, if we tokenize this sentence up here by word, it would look something like this. So now every word is its own item. Okay? So at this point, we've done some tokenization. And now every single item is its own word. So at this point, we can remove things called stop words. So stop words are words in a language that have very little meaning. So every language out there has its own set of stop words. So you'll see that English has its own set of stop words, including things like the or words like that. So it's very common at this point. If you have all these words, you can remove these stop words because they're not going to add much meaning for the machine to process. So if we remove the stop words, these are the words we end up with. And at the end of the day, you end up with just these words here. So we went from that really messy looking data to just 6 words here. And it's much easier for the computer to process. So this type of format for the words, within NLP, it's called the bag of words format. Because if you think about it, it's saying that this document here is essentially just a bag of words. And the order of the words doesn't really matter. It's just a group of words thrown into a bag. So it seems like an oversimplified way to represent text data, but it's actually really powerful. Just using bag of words, you can do a lot of analysis, which I'll show you later as well. OK, and then finally, we're going to put this all into a matrix. So this text here was just for John Mulaney's skit. But what if I want to, within one table, include data for John Mulaney and Ali Wong and Dave Chappelle? Well, I'd have to put that all into a matrix. So the reason we put this into matrix is because we want to store these terms for multiple documents. So at the end of the day, you get this document term matrix. So this was our goal. We wanted to create a matrix that contains for every row a different comedian or a different transcript or a different document. And then every column here is a different term. And then all the values inside are the word counts. And so if you think about it, we started with, for every comedian, a big transcript of really messy data. But using those steps of cleaning, tokenizing, and putting it in a matrix form, we've been able to really simplify it and put it into this document term matrix that we can now easily use for analysis. It's almost just like having numerical data at this point. It's very easy to process. So at the end of the step, we've created this document term matrix. And the way that we do this is within scikit-learn. Again, this is Python's machine learning library. There's this function called count vectorizer, which helps us create this document term matrix. So you can do a little bit of data cleaning ahead of time, and then you put it in count vectorizer. It creates this matrix for you, and then you're even able to remove stop words along the way. So count vectorizer is a great tool for this. So again, our goal at the beginning of this was to get our data in a clean standard format for analysis. And now you see that we've gotten it in two standard formats. Just a general corpus with every comedian and the transcript, and also this document term matrix with all the documents, the terms, and all the word counts. So to summarize, the input into this data step down here was how is Ali Wong's comedy different? And we first gathered our data, we scoped our project, then we put that data into a standard format using data cleaning techniques, and our output is a corpus and a document term matrix. So let's get into the Jupyter Notebook. Okay, so for those of you who have a Windows machine, what you should do at this point, I said it in the steps, but you want to launch Anaconda Navigator, open Anaconda Navigator and then launch Jupyter Notebook. And then within the browser that opens up, you want to navigate to that, to the first notebook, data cleaning. And then if you're on a Mac, you can just go to a terminal and then type in Jupyter Notebook. And then you see this window pop up. And if you navigate to the folder, you can see all of the Jupyter Notebooks here. So at this point, I just wanted to point out this extension, IPYNB. That stands for Interactive Python Notebook. So it's been rebranded as Jupyter Notebook. But you'll see whenever I talk about a notebook, it's anything that has that extension, .IPYNB. So we're going to go to this first one here called data cleaning. OK, has anyone here used Jupyter Notebooks before? OK, a lot of people, great. So one of my favorite shortcuts in Jupyter Notebook is Shift-Enter. And what Shift-Enter does is it allows you to run a cell. So at the very beginning, we have our introduction here, our problem statement. And I'm doing Shift-Enter the whole time. So you're able to actually run the cells. So I'm going to walk through the code here of what's actually happening. So for this first section, my goal is to get the data. Do you guys remember what the libraries were that I used for this section? To get the data? Requests and Beautiful Soup. Yep, those are the two most important ones for web scraping. So what I'm doing here is I am first importing requests and Beautiful Soup. And then here, I'm creating a function that will pull the transcript data specifically from the scraps from the Loft website. So if you take a look at that, I can go to scraps from the Loft. And the way I scrape data is you can inspect an element in this browser here. So that is Command-Shift-C. And then you can't really see it right here. But you'll see that behind every web page, there's a bunch of code here. And so for me, the code that I specifically want is this transcript data. And so if I highlight over this, you can see here that all this transcript data is in this div class called post content. So that's how I was able to identify where that transcript data was. So if I go back to this function here, you can see what I'm doing is first I'm using a request to get all the data from that web page, that URL, and then I'm soupifying it next in this step called Beautiful Soup, basically telling Python that this text is actually an HTML document. I want to read it as an HTML document. And then this part is where I find that specific class called post content, which I knew by hovering over that section of the web page. I knew that that section was called post content. And then I want to find all the paragraphs in there and pull out the text from those paragraphs. And that's it. That's my simple web scraper just from this little function here. And so at this point, I've listed all the 12 URLs that I want to scrape. And then I scrape them. So this cell here, if you uncomment it, you can actually scrape it. It takes a few minutes. So instead of all of you trying to hit this website, which is already a little bit slow to begin with, I've pickled the files here. And then you can just load the pickled files here. Oh, let me do that again. All right. So once you load in the pickled files, you can see that I've created a dictionary here. And in my dictionary, every key is a comedian. And then every value is the transcript. Does anyone have any questions so far? OK, great. So that was the data gathering step. So it looked really simple there, but that actually took me a whole day to figure out, because I was trying to figure out like where on the website all this content was and how to write it in a short format. So that, it does take a while. Just wanted to put that out there. OK, so the next step is to clean the data. And so what were some of the things you can do to clean data again? That are not, that I'll hide there. Yeah, remove words with numbers, lowercase, punctuation, right? So these are a lot of the common data cleaning steps up here. And then there's some more data cleaning steps for later as well that I'm not going to talk about today, but things like lemmatization and stemming. So what that means is you can take words like driving, drive, drives, and it knows that those are all the same words, and it could group them together. Parts of speech tagging, bigrams, and so on. There's a lot you can do, but you want to start simple. And so we're going to start here with just these common data cleaning steps. So I always like to keep looking at my data to make sure that it looks right. So I'm just going to, again, see that I have this dictionary called data, that I've called data. All the keys are the comedians, and then all the values are the transcripts. And so the next thing I'm going to do is I'm going to create a function that takes this transcript text and puts it into one large chunk of text. So right now, if you remember when I scraped the data, the data was split into lots of chunks of paragraphs. And so I put that all into a list. So I had a list of lots of text, which is kind of tricky to deal with. With text data, a lot of times, you just put it into one giant string. It's a lot easier to deal with. So in this case, I'm using this function to put all that data into just one giant string. And that's this part here. So now I've created this data set that has a key of a comedian, and then the value is, instead of a list of text, it's just one giant string of text. And at this point, you can keep your data in this dictionary format, or what I like to do is I like to put it into a data frame, because I'm very used to working with pandas data frames. So what I'm going to do here is I'm going to import pandas. And pandas has this nice function that allows you to take a dictionary and make it into a data frame. So at this point, if I run this, you can see that I had that dictionary of comedians to transcripts. And now I've been able to put it all into this nice data frame. And this was one of the formats that I wanted. Which format was this? I think I heard it, Corpus. So at this point, this is not the document TermMatrix just yet. This is just the raw corpus, right? Because I have just all of the transcripts. Right? So my column is just transcripts. So not yet the document TermMatrix. This is just a corpus. OK, so that was the easy thing to create, was just the corpus. So the bit harder thing to create is that document TermMatrix, where instead of every column being, so in that case, my column was just a transcript. Now I want to create a different column for every single term. So the way I'm going to do that is I need to first clean the data. Remember, we have to use regular expressions to clean that data. So again, I just like to look at my data to make sure it looks good. It does. And at this point, I'm going to start applying data cleaning techniques to create that nice document term matrix. So I'm importing RE, which stands for regular expressions, and then string, which allows me to get all the types of punctuation out there. So I'm going to create a function that allows me to clean my data. So you can see at this part, I am making all the text lowercase. This next regular expression here is a bit trickier. So what I'm doing here is, if you look at this data up here, I don't know, let's see. Okay, so if you look at this data up here, you'll see that there's data in brackets. And I wanted to get rid of the data in those brackets, because those aren't actually part of the routine. You can see that they're just sounds. And so that's what this regular expression here is doing. It's saying anything that's within these square brackets, if you have square brackets and there's some character in them, then get rid of that whole thing. So that's what this line is saying. What this regular expression is saying is we have string.punctuation, which is just literally like a list of punctuation marks. And so it's saying if anything is any of those punctuation marks, then get rid of it. Mm-hmm.
But don't you want to get rid of the text after the announcer saying stuff, because that's not the stand-up comedian speaking?
You said you want to get rid of this part?
Like after announcer, that's the announcer speaking.
Can you give an example?
Yeah, Joe says, "Ladies and gentlemen, welcome Joe Rogan."
Oh, yeah.
So those
yeah.
aren't the
I see what you're saying. Yes. So that would be great. So I didn't do that, but yes, that would be great. So you'll notice, like, in these two sections, it says announcer, and then it has that other one. Yes, that would be a great second round of cleaning to do. OK, so going back here, though, so I'm getting rid of, just very easily for a first pass, I'm getting rid of everything in square brackets, the punctuation. Then does anyone know what's happening in this one right here?
The number between the digits, or just the digit?
The numbers, yeah. So what this is saying is -d, these are all the digits. And then W is alphanumeric characters, so A to Z, 0 to 9. And then the star is 0 more times. So it's saying if you have a number, and then there are any letters or numbers surrounding that number, then that means that that's a word that contains a number in it. And you want to get rid of any words that contain numbers in them. So these regular expressions are a bit harder to decipher. So I encourage you, after this tutorial, to go back and look at them to understand them a bit more. So right here, this is my first round of text cleaning. Right? So it's just those three basic things. And then the one extra thing I added there was the square brackets. So let's run that. And then you can see here that our data looks a little bit cleaner. Do you notice anything here that hasn't been cleaned?
Like single letters.
Yeah, there's some single letters there that are kind of weird. The first thing I noticed when I looked at this was some of my quotes didn't disappear. And it's because the string.punctuation didn't capture this particular type of quote. So then I went back and I like copy-pasted these quotes. And then I did a second round of cleaning. So I added those specific quotes. And then I also noticed that these line breaks are in here. The \ns are in there. So then I did that as a second round. And actually, those square brackets I mentioned, I actually didn't add those into my data cleaning step until like 3 days after I did this analysis. And I realized it actually helped my case, but it helped me more if I added that in there. So there are always more ways for you to clean the data, but I would say like 2 rounds is a good place to start. So if you apply that second cleaning step, I would say this is looking cleaner. There are these like weird EIEIO things. There's things that the announcer's saying, but it's pretty good to start. So we're going to move on from here. So this is what I mentioned here. This could go on forever. Just stop at some point and move on with your analysis. So at this point, we've organized the data into a corpus and a document term matrix. And we're going to pickle them because we're going to use them in later files. So first, we have this corpus. which is just every comedian and the transcript. And then you see down here, I'm going to add the full names next to it as well, because I want to use that for my data visualizations later. And then I'm pickling it. So you can see corpus.pickle. I'll use that later. And then there's also this document TermMatrix. So this is where we're going to use count vectorizer from scikit-learn. And the way that you use count vectorizer is you first instantiate a count vectorizer object. And what you can put in there is stop words. So if I say stop words equals English, it automatically knows that I don't want those stop words as columns, which is really, really helpful. There's a ton more that you can do with count vectorizer. You can even say, I want to include bigrams as well. So anything that's one word, I want to have that as a column. Any combination of two words, I want that as a column as well. So it's super powerful. Another trick that I like in Jupyter Notebook is if you do Shift-Tab. Oh, here, let me run this first. If you do Shift-Tab, you can see all the documentation behind a function. So if I expand this, you can see there's a ton of things you can do in here. You can strip the accents. It defaults to making everything lowercase. I mentioned the n-gram range here. There's just a lot you can do in there. So after you create that count vectorizer, you can fit it onto your data. And we're specifically fitting it onto our transcript data. And then these two lines are a bit trickier. But you convert it into an array, and then you label all the columns. But just know that if you can just copy and paste this code for future use. The main thing you have to know here is you have to specify the stop words, and then you have to put in your clean data, text data here. And at the end of the day, you get this document term matrix. So remember, every document, and then all the terms. So you can see that this is a pretty big matrix. It has 7,000 columns. So if you include things like bigrams, those pairs of words, this will really blow up. But I found for that a lot of analysis, it's really useful to include those as a second pass, because then you'll find really meaningful things in your data. So at this point, you can pickle it. Oops. I'm going to pickle this for later use. And then I'm also going to pickle two other things. I'm pickling data clean. And data clean is this data frame from up here. So you can see this is before I put it into count vectorizer form. It's just the clean data where I removed all the punctuation. So I pickled this for later use because we're going to use it for one other thing. And then at the very end, I also pickled the count vectorizer object, which we're going to use for a later thing as well. So that's it. There's some additional exercises you can do on your own after this tutorial. Mm-hmm.
What do you mean when you say pickling something? Are we just like writing to a PTL file?
So what's happening is it's just serializing it. And so it's just think of it as you're taking that object and you're just saving it as a file on your computer. So that later you can just call that and then you can open it up in the next document. Does that make sense? So like if you see that I've pickled a file here, so once I ran that pickle step, you can see that it created this pickle file. So in the next notebook, I'll open a pickle file, and then you can see that the object pops up again. Mm-hmm. What's that?
Is there a specific reason to create a?
So pickle file is just the easiest thing you can create. Like you can also maybe like compress it in some way, but pickle file is not compressed at all. So it's just like a very simple way to just dump that object into a file that you can use for later.
And it just persists within the file that you saved it in then?
Yep, it just stays there. So, okay. How's everyone feeling? Pretty good? Okay, so then let's move on. Okay, so we've cleaned our data. So the next step is EDA. And for EDA, the input into this step is your text in some standard format. So again, we've created our corpus and our document TermMatrix. And then the goal for EDA is to summarize the main characteristics of the data, preferably in a visual way. So if you remember from our simple example, that's when we created the scatter plot, and we were like, okay, there's definitely a positive correlation, and also we see an outlier. And then the output of this section is just to see if our data makes sense or not. So you might have heard the term or the phrase garbage in, garbage out. So that means if you put in garbage data into your model, even if you have the coolest model, it's not going to be, your results are not going to be good. So you have to do this step to make sure your data is actually good. So if you think about our data set with all our transcripts, what are some ways that you think you can explore that data? Perfect. Frequency counts, like word counts. Anything else?
Named persons.
Named person? Great idea. Like seeing like the actual proper nouns that they use. What's that? Sentiment. I would say that's like a little bit more advanced analysis, but yeah, these are great ideas. Like you just want to get an idea of what's going on in your data. And so I thought of 3 things that I want to get out of this data. So the first thing I'm going to do is I'm just going to look for top words. That's the most obvious one. So for every comedian, what are the top words that they use, right? The second thing I thought of is taking a look at the vocabulary. So maybe some comedians have a larger vocabulary than others. That might be interesting to look at. And the third thing is the amount of profanity. So I didn't realize that this would be really a thing until I looked at the top words, and there's a lot of swearing. So I was like, maybe I should see how much comedians swear. So those are just some things I decided to look at. This is really up to you. Whatever is interesting to you that would help you figure out if the data makes sense or not would be good to do here. So how did I find the top words? Well, the first thing you want to do is figure out, okay, we have our data in 2 standard formats, right? The corpus and the document term matrix. Which one do you think would be better for figuring out the top words? Yeah, the document term matrix, right? Because you already have everything in this, every word as a column. So it's very easy to aggregate your data at this point. So the whole reason we did all that data cleaning and standardization was so our life would be really easy at this point. Okay, so we got this data. The next thing we have to do is aggregate. So how do we aggregate this data to find the top words?
Sort it to largest number.
Perfect. You have to, for every comedian, select the columns with the largest value. Basically, like sort across the row and then find which words have the highest word counts. Okay, so we've got the data. We've aggregated the data, and now we have to visualize it in some way. So let's say we found the top 30 words for every comedian. What's the best way to visualize that?
Word cloud.
Word clouds. Okay, so it's funny because where I teach, half of us love word clouds and half of us hate word clouds, and I love word clouds. So I never expect people to say word clouds when I'm teaching, but I'm so glad you brought them up because I really like word clouds. So it's a great way to visualize text. So you can see here, this is Ali Wong's word cloud, and here's John Mulaney's word cloud. And so what we'll do in the notebook is I'll show you how to create word clouds for all the comedians. Yep.
What is another alternate way?
What's that?
What is an alternate way?
Sure, you can do like a bar plot.
Okay.
So something like more classic. Word clouds are specific to text, but yeah, you can create like a bar plot or. So the bar plot is the easiest. If you're comparing 2 words, you can do a scatter plot. Okay, so you visualize this, but what was the whole point of this? Why are we visualizing this? What's that? We want to find the top words. Do you remember why we wanted to find the top words?
Why is she different from everybody else?
Yeah, we want to know why she's different from everyone else. We want to see if these results are actually making sense. So when I first did this analysis, I didn't do as much data cleaning as I showed you. And when I was getting these word clouds, like they did not make sense at all. They just had like very common words in there. I hadn't removed stop words, and so they didn't look very good. So it took a lot of cleaning to get to this point where it made sense. So that's where EDA can help. So you look at these word clouds and you're like, okay, do they make sense? If they don't make sense, then you have to go back and you have to do more data cleaning until this part makes sense. Yep.
They look a little different than normal word clouds, in that there's just a few really big words
Mhm.
and a lot of small ones, whereas word clouds you're familiar with seeing have a more normalized distribution.
Mm-hmm. Yeah, that could be the case. So I'm not sure the exact logic behind the word cloud package, but it has to do something with that. I'm sure you could tweak the parameters. OK, so I mentioned the last thing you want to do is you just want to take a look at the visualizations and see if your data makes sense and figure out if you have to clean your data some more. And then also, you can get some initial findings from this. So how are the comedians different from each other? Well, you saw that Ali Wong, let's see. Oops. Sorry, guys. You see that she says get a lot, and then John Mulaney talks about Bill Clinton a lot in his skit. So those are some ways you can see that it's different. Oops. It is. So it is a bigram that I detected. OK, so at this point, these are the EDA steps that we followed. So we figured out what format we need the data in. So for finding the top words, we needed the data in the document TermMatrix format. Then we had to aggregate that data, visualize it, and then see if it made sense. So what we're going to do in the notebook next is we're going to do this for 3 things. So top words, which we create word clouds. I'm going to look at the size of the vocabulary for every comedian, and then the amount of profanity. So the way I'm going to do this is I'm going to use word cloud specifically in it's the word cloud package. You can create word clouds. And then there's also matplotlib, which is the most popular data visualization package in Python. So one thing I want to note is within the README file, I updated the README file about 2 days ago. There's an extra step you have to take to download word clouds. So if you look at that README file, there's a conda install step for you to actually download word cloud because it's not included with the base Anaconda navigator. OK, to summarize what we did for this section. The input into this section was our standard document formats. What we're going to do here is we're going to do a ton of EDA to see if our data makes sense. And then the output is to find some big trends in the data and see if they make sense. So to the notebooks. All right. I'm going to go to the second notebook here. And what we're going to do here, the first thing is I'm going to read in the Pickle Files. So someone asked earlier about how this part works. So within pandas, what's really nice is if you use pickling in pandas, like you pickle a data frame, it's really easy to read it again. So if I import pandas, you can see within pandas there's a read pickle function, and I can specifically use that to read in a data frame. So here, I've read in my document TermMatrix, but one extra thing I've done here is I've transposed it. So now it's a term document matrix. And the reason that I did that is because now my aggregations will be a little bit easier. So I talked about, like, I wanted to find the top words for every transcript. Well, if I didn't transpose it, it's harder to do things across rows than it is to do things over columns. So that's the reason I transposed it here. I just wanted to mention that. So my data here is now a term document matrix. And so let's say I wanted to find the top 30 words for every comedian. So what I've done here is for every comedian, I've looked in that data frame, and I see for Ali Wong, these are her top words and how often they occur. And so I'm going to do that for every comedian. So these are the top 15 words said by every comedian. So if you take a look at this, what do you think about these top words?
People say like a lot.
Yeah, people say like a lot. And so like is not part of the standard English stop word list. But if everyone says like a lot, it's not going to be really meaningful in your data, right? And so what you can do is you can actually add these common words to your stop word list. So what that means is in my document term matrix, I'm going to remove this term, in your case, like. So what I'm going to do here is I'm going to, I'll show you. So I'm going to first pull the top 30 words for every comedian here. And then I'm going to use counter, which is super helpful. So what's going to do is going to look at my list of the top 30 words for every single comedian. And then I'm going to see how many documents contain that word. So at this point, you can see all 12 comedians have like as one of their top 30 words. All 12 comedians have I'm as one of their top 30 words. So these words aren't really meaningful. So I'm just going to set a limit. I'm going to say if over half of the comedians have one of these words as their most common words, I'm going to say it's a stop word. I'm going to add it to my stop word list. So you'll see here, these words are in a lot of the words from the top comedians. So I'm going to, here, what I'm going to do is add them to my stop word list. So I'm going to walk through you through a couple steps here. So first, I'm importing count vectorizer, which we used before. I'm also importing text. So text is what actually contains the stop word list. What I'm going to do here is I'm going to first read in the clean data. So if you remember, that was my corpus that had all the punctuation stripped. And then I'm going to add new stop words. So here, what I'm going to do is there's already English stop words out there, and I'm going to add to it my new stop word list. And so now I'm going to recreate this document TermMatrix with my new stop word list along with my clean data from my last notebook. And then at the end of that, I'm going to have a new count vectorizer object that includes my new stop words, and a new document TermMatrix that excludes those stop words as well. So I run all that. At this point, I have a new document TermMatrix that doesn't have those stop words in it anymore. So at this point, we can make some word clouds. So this part will only run if you've done this additional install. So if you're on a Mac, you can do this in your terminal. If you're on a Windows machine, you can do this in your Anaconda prompt. And you just type in conda install conda forge word cloud. And so I've created my word cloud object. And then to actually plot it, you can see here. So these are the word clouds for all the comedians. So what can you tell from this? There's so much swearing. Like, I was so surprised with the amount of swearing, which is why I added the profanity step. Yeah, there's a lot of swearing. And what I found from this, remember my original question is, how is Ali Wong different? I noticed that she says okay a lot. I say okay a lot. She talks about her husband. I talk about my husband. I think this is all funny. So if I look at this, this makes sense to me, and I've come up with a couple of findings here. OK, so the next thing I'm going to do is look at number of words. So my goal here is to see how big of a vocabulary everyone has. And so the way I did this is, first, I went for every comedian. I looked at the number of unique words that they used. And then the other thing I did, I was thinking maybe I can look at the speed of each comedian. So I went on IMDb, and I looked at how long everyone's routine was. So I added that here. So this table I created has every single comedian, the number of unique words they've used, the total words that they use throughout their routine, how long that routine was, and so I could calculate this words per minute. So the two columns that I care about are the unique words that they use, the number of unique words that they use, and then also the number of words per minute that they say. So now that I have this table, what's the way I can visualize? Yep?
Is the runtime the time of the show or the time of when the comedian gets on stage?
So I just had the time of the show, but you're absolutely right. Like, if I wanted to be more specific, I would need to know the specific time that the comedian comes on stage.
How did you find that runtime?
I went on IMDb, and I just manually went to each comedian, looked at their runtime. Yeah. I could add it to my scraper too. So, okay. So at this point, what can I do? This is kind of hard to read. So. Yeah, that's a great idea. I could take the average of the unique words and then see who's above or below that. Anyone have any other ideas? Oh man, you can do some clustering too. We'll talk more about that later. So for me, I like to visualize in very simple ways. So what I've done here is I've just created some bar plots. This is pretty simple. A great idea would be to add that average piece, like a line here or a color here for average. But you can see that Ricky Gervais and Bill Burr have a big vocabulary, and Louis C.K. and Anthony Jeleznik don't. And here are some things about words per minute. So I did this, and I found that my analysis wasn't really interesting. But it's something to try, and not finding anything is something in itself. So I just did this analysis, didn't find it very interesting. And so then I went to my last bit, which was looking at the amount of profanity. So when I looked at all the word clouds, I found that the S word and the F word were said a lot. So I was like, OK, why don't I just create a scatter plot to see how often those things are said. So that's what I'm going to do in this section. I'm just going to create a scatter plot of bad words. So this here, this is number of F words, that's number of S words. And what can you tell from this? Bill Burr used a lot of S words and just profanity in general. Yeah, I was really surprised. I don't know Joe Rogan, but he's using 2 F words per minute in his comedy, which is crazy. And then on the other end, you have Mike Birbiglia, who has 0 swear words in his whole routine, which I thought was pretty interesting. So just from EDA, I haven't done any fancy analysis. You can see I've come up with some interesting things here. And I do think my profanity plot is my most interesting thing from my EDA section. So, yeah. That's a great question. So I didn't do any stemming. So what I did was I looked at the most common words, and then when I looked here, I saw that there were variations of the F word, and I just put them all in one. If you could do stemming, although I don't know if the stemmers in NLTK include profanity. So that's probably something I'd do manually. OK. So the side note I wanted to mention here is the whole goal of EDA was to take an initial look at our data and see if it made sense. And my conclusion is it does for a first pass. And yes, there's always things that could be better, but it's good to get something done quickly. And so all my students know my data science motto is let go of perfectionism. Because I always have students that come in, they want everything to be absolutely perfect before they move on to the next step. But I'm like, you got to move quickly. So just do something. You know there are things wrong in it, but it's OK. So my data science and my life motto is let go of perfectionism. Just wanted to throw that out there. OK, so we're at about the halfway point, and we've been here for a while. So I want to give you all a break. So let's get back together in about 5 minutes at is it 11 o'clock? We have now completed the EDA step, where we've explored and visualized the data, and we've gotten a couple interesting findings from it as well. So this last part now, second to last part, is the most interesting part. So this is actually looking at all of the NLP techniques. Oh, there's an extra. So now we're going to be looking at the NLP techniques. So our input into this is we have clean data, and we verify that the data makes sense. And now we're going to do these more advanced analytics techniques, including sentiment analysis, topic modeling, and text generation. And our output is going to be additional insights to help us answer our original question. So these are the 3 techniques we're going to be going through, starting with sentiment analysis. So who here has heard of sentiment analysis? OK, who here has applied sentiment analysis? OK, that works. So the input into sentiment analysis, so remember we have our corpus and we have our document TermMatrix. For sentiment analysis, we want to input in our corpus. And the reason for that is because, remember, when we had our document TermMatrix, it was in a bag of words format. So what is a bag of words format again?
Collection of all the words.
Yeah, it's a collection of all the words, and order doesn't matter. But the thing is, with sentiment analysis, order does matter, right? So if we have the term great, and we have the term not great, those are going to mean very different things. So we want to preserve that order. So our input here is a corpus. And what we're going to use for sentiment analysis here is a library called TextBlob. So earlier I talked about NLTK, and NLTK is the library that everyone uses for natural language processing in Python. But TextBlob was built on top of NLTK, and it makes it a lot easier to use. And it also includes some additional functionality, such as sentiment analysis, and also, what was the other one? It like fixes typos. So it does all those things, but I would say it does it in a very, very basic way. So keep that in mind. So for the output of this, for every comedian, what we're going to do is we're going to look at their entire transcript, and then we're going to give that transcript an overall sentiment score and an overall subjectivity score. So the sentiment score is how positive or negative they are, and then the subjectivity score is how opinionated they are. So let's take a look at what this code looks like. So this is literally all the code for sentiment analysis. So you would import TextBlob, and then you would say TextBlob of some text. You do .sentiment, and then you get this as an output. So polarity is a number between -1 and +1. And so a polarity of 0.5 would mean I love PyOhio is generally a positive statement, which is right. And then subjectivity is how opinionated you are about something. So that's a number between 0 and 1. So the more subjective you are, the more opinionated you are. So love is an opinion. So you can see that that's a bit higher on that scale. So great, let's jump into the notebook. But wait, don't jump into the notebook. So I mentioned this a little bit before, but if you jumped into the notebook at that point, then you would fall into that danger zone I talked about, because you only understand at a very high level what's going on. But before you import and use a module, I highly encourage you to understand what's going on behind the scenes. So I'm going to go into a little bit more information of what's actually happening. So the way that TextBlob sentiment works is there's this great linguist, Tom de Smet. So what he's done is he's gone through all these words in the English language and manually labeled them as positive sentiment, negative sentiment, and so on. And this might seem kind of crazy, but there are a lot of linguists out there, and this is what they do. They've created these amazing, incredible databases of the words of the English language. So you might have heard something called WordNet. So WordNet is created by this group of researchers at Princeton. And what they've done is they've said these words are all very similar to each other. These are the definitions of these words, and so on. So they've actually kind of mapped out the English language manually. And so there are a lot of sentiment, I would say, like lexicons out there. So people who have gone through all the words, researchers, linguists who have gone through all the words and labeled them. So the one that TextBlob uses is this specific one that was labeled by Tom de Smet. And the reason I know that is because I went to GitHub and read some of the documentation, and it would tell you this. So what does this mean? So let's take the word great. So if you look into that big dictionary from the last slide, if you just pull out some key features here, you'll see that the word great actually shows up in that list 4 times. These are the WordNet IDs. So again, WordNet is this big dictionary that was created by Princeton, and a lot of people will reference it in the NLP world. And so they'll have different WordNet IDs, and everything in the WordNet dictionary is labeled with parts of speech. So JJ stands for adjective, and then different meanings of that word. And then you can see here that this specific linguist has labeled these as a certain polarity and a certain subjectivity. And so how do you think TextBlob aggregates all of that? So overall, if TextBlob saw the word great, how do you think it would decide what to do?
Depend upon the words that are around it.
You would think it does something fancy like that. It just literally takes the average.
Oh, really?
Yeah. So this is what I was saying, like TextBlob's features, it sounds really fancy, like fixing typos and sentiment analysis, but it's very, very basic. but it's OK because it's a good first pass. So these are all good things to know before you just use the module. So let's look at some examples. So if I just did TextBlob of great, you would see that that polarity 0.8 is just the average of that column, and the subjectivity is just the average of that column. If I did not great, what do you see as a change here? Polarity, what's changed? It's negative. So if you look at the documentation, what's actually happening is whenever it sees not before a word, it multiplies the polarity by 5. So this is a rules-based approach to sentiment analysis. If you see very before a word, what it does is multiplies both those scores by 1.3, and then it caps it at 1 for polarity. So again, rules-based approach. And then if you do I am great, you can see that that has the same score as that first line because I and am don't have any sentiment. Yep?
Does TextBlob take into account punctuation? So if you say great,
Mm-hmm.
you say great, or you say great, that great is like exclamation.
I'm not sure, but I would hope so. I'd have to look at the actual code to see what's happening, but that makes sense. Like an exclamation mark would add some meaning to it. So, so this kind of gives you an idea of what's happening behind the scenes. And it makes it, when you do dig deep into what's happening in the modules, you don't just take the module to be magic.
It does take the exclamation, add exclamation.
That's great.
Make the polarity to 1.
That's great. There's the answer to your question. Thanks for answering. OK, so at the end of the day, what TextBlob does is at first, if it sees a word, it'll average all the subjectivity and polarity scores. And then at the end of the day, it'll look at your entire text and then average together all those scores. So not the most, OK, well, before I say that, so the output will be every comedian's going to be assigned 1 polarity and 1 subjectivity score. And it's not the most sophisticated technique, like I said, but it's a really good starting point. Because, so this is a rules-based approach, and you can also do knowledge-based techniques. So this is more, if you're into data science, and you know about classification techniques that are out there, you can use one of those classification techniques as well. So how that would work is, the most popular data set to do sentiment analysis on is this movie reviews data set. So for every movie review, it has a bunch of text, and then it's labeled as, this is a positive review, this is a negative review. And then you'll use some more advanced technique like naive Bayes or logistic regression to see what's the combination of words that, that gives a movie a positive review. And so that's a more advanced technique that if you're interested in, I highly recommend you look into after this. Yep?
Why is naive Bayes the most common technique used in NLP?
Yeah, that's a great question. So with naive Bayes, the major assumption there is that all your features are independent. So it's saying, like if you're trying to predict how good you will do on a test, all the things that could predict how well you're going to do on the test, like number of hours studied or how high grade you got on your last test, like that, those are not related to each other. So typically, if you use a standard algorithm that's not naive Bayes, you don't have to assume that, sorry, let me just summarize my thoughts. So if you're using something like naive Bayes, it assumes that each of those features is independent, so that they're not related to each other at all. And with other types of analysis, you usually can't make that assumption, but with text data, it is OK to assume that those are independent. And so it just ends up working very well with text data. Any other questions? All right. OK, so now that we've kind of understood how TextBlob works, let's jump into the notebook. All right, so for this, we are going to go into Notebook 3. And for this, you're also going to have to do an extra conda install. So again, instead of reading in the document TermMatrix, we're going to read in the actual corpus that has all of the words in order. So again, it's very easy to do TextBlob. All you have to do is do textblob.sentiment, and you end up with those scores. So again, that was very easy to do. Just encourage you to figure out what's happening on behind the scenes. And then if I map this, this is what I see. So on the x-axis, I have positive and negative. On the y-axis, I see facts and opinions. So what can you tell from this graph? Yeah, he's pretty negative. Yes, he is. And so if I want routines, I want to see comedians similar to Ali Wong, what might I recommend? Yeah, like whoever's close by, right? John Lee, Richard, and so on. So there you go with sentiment analysis. So that was pretty simple. And so another thing I did was I wanted to see the sentiment of a routine over time. Because one of my friends actually did this analysis on Disney movies and saw that there's a common pattern throughout all Disney movies. It gets it starts very sad, and then it gets sad, and then very happy. So I wanted to see if there was anything with comedy routines in that. So what I did was I took every data, every transcript, and then I split it into 10 pieces of text. And so I created this new list, and it has 12. It has a different element for every one of the 12 comedians, and then you can see every comedian, their text has been split into 10 different parts. And what I want to do is calculate the polarity and the subjectivity for every single piece in there. And so if you plot that out for one person, you can see this is their sentiment over time. And then at the end, I created this sentiment, all these plots for all the different comedians. So anything you can tell from these plots immediately? Yeah,
Most of them
pretty interesting.
drops in the very beginning, so they seem like they start positive.
Maybe. I mean, yeah, there's a peak here. What's that? Yeah, that's kind of what I took out of this. It's Ali Wong is pretty consistently positive, and so I wanted to see are there any other comedians that are pretty consistently positive. Tom Lee again, Louis C.K., Mike Birbiglia. And so with this extra sentiment analysis, I was able to find some extra interesting things about my data. So here's some additional exercises for you as well. All right, so that was sentiment analysis. So the next thing I want to talk about is topic modeling. So this is probably the most complex thing we'll talk about today, but I'll try my best to explain the idea. So for topic modeling, the input into topic modeling is a document term matrix, because order doesn't matter here. So again, with topic modeling, what we're trying to do is we have all these documents. We want to see what are the topics that are being said in these documents. And so we don't really care about the order of the words here. We just want to know what are the words, what's the bag of words that's in each topic. And then the library we're going to use here is called gensim. So gensim was built specifically for topic modeling, and it actually has different ways of doing topic modeling, but the most popular one is called latent Dirichlet allocation, which is most commonly known as LDA. And then we're also going to use NLTK for some additional parts of speech tagging, which we'll go through in the notebook. And then our goal at the end is to find the various topics or themes across the comedy routines. So I'm talking about topics in a pretty vague way right now, so I want to show you an example. Before I go through that, so this technique is called latent Dirichlet allocation. So latent just means hidden, and Dirichlet is a type of probability distribution. And those are the basic ideas that you have to understand from this. So I'm going to talk about probability distributions coming up, and then hidden, it means that what's happening is I'm looking at the text in terms of probability distributions, and I'm going to find hidden topics from that. So let's go through a concrete example, because I think this will make more sense. So let's say I have these 5 documents here. If I applied LDA on this set of documents, what would happen is I would get an output that looks something like this. So it would say, that document is 100% topic A. This is 100% topic B. This is split between topic A and topic B. Okay? So the way to think about this is, earlier I was talking about latent, right? Latent means hidden. So these are topics that were hidden in these documents before that I couldn't find, but using LDA, I'm able to find those topics. That's the latent part. Dirichlet is all about probability of distributions. And the way to think about this is you see that this document here is a mix of topics, topic A and topic B. Or a fancier way to think of that is this document contains a probability distribution of topics. So when I say probability distribution, I just mean it's a mix of these words. So again, this document is a mix or probability distribution of these topics. Yep?
How will you determine which is topic A and topic B? Would it just look at all the documents and find something common or something?
Great question. That's all we'll go through next. OK. So at this point, what you would do is, so I talked about this document ends up being a probability distribution or a mix of these topics. In addition, every topic ends up being a mix or a probability distribution of these words. So this is what you would get as an output to LDA. You would see this topic contains this much about bananas and kale. This topic contains a lot of words about kittens. So what do you think topic A might be about? Food, right? And what would topic B be about? Animals. So now you can go back to your documents and say, that document's about food, that's about animals, this one's about food and animals. So that's the whole idea of topic modeling. I have these documents, I don't know what the topics are, but then I can figure out what the topics are and then see for every document what's the mix of topics, and then for every topic, what's the mix of words. Okay, so with latent Dirichlet allocation, it's all about these probability distributions, or these mixes. So again, just to reiterate, I said this a couple times, but every document is a mix of topics, and then every topic is a mix of words. So you can see here, this food topic, it has a lot of things about bananas and kale and frogs, and then animals has a lot about kittens and puppies. So that's a general idea behind LDA. And the way that it actually figures out which, what the topics are is it goes through these steps. So first is, again, you want LDA to learn about the topic mix in every document, and then the word mix in every topic. So within each document, what are the topics in there? Within each topic, what are all the words that are in there? So the first thing you do is you choose the number of topics that you think are in your corpus. So people typically start with 2, and then you just build on from there. And then what it does is it goes through every single word in every document. So here's my example up here. Let's say we have this document. It goes through every single word, and it randomly assigns it a topic. So it might say, I is part of topic A, like is part of topic B, and so on. It just makes a random distribution of topics. OK, and then this is the most complex part. So this is where it goes through every word, and it updates those topic assignments. So what's going to do is it's going to look at a word. So let's say we're going to say bananas. Let's say it looks at bananas, and right now banana is assigned to topic A. Sorry, banana is assigned to topic B. So banana is assigned to animals. Does that sound right? No, right? So you want it to update. So this is how LDA works. It looks at every word in the topic assignment. So like bananas, let's say it's assigned to topic B. It's going to look at that and say, should I reassign that to topic A, or should it stay topic B? And the way it decides whether it should reassign it or not is it'll look at that word, and it'll see how often does that topic that it's assigned to occur in that document. So right now, banana is assigned to animals. How often does animals actually occur in that document? That's the first thing it looks at. And then it looks at that word and see how often does that word occur in that whole topic overall. So how often does banana occur in the topic about animals? And in those cases, those probabilities are both pretty low. And so it's saying, OK, well, I should reassign that to the other topic then. So I'll re-update that topic assignment to topic A, which is about fruit or food. So that's like the bulk of what's happening. So what's going to happen is it's going to go through every single word, every single document, and then try to figure out which topic should be a part of.
What would it do in Q?
It might end up in both. Great question. It would depend on your corpus. But it could absolutely be part of both. So what happens at this point is it goes through multiple iterations of this. So it does the random assignments. It'll go through every single word in the whole corpus, and that'll be iteration 1. And then all the topics will be slightly better. And then it'll go through it again, iteration 2. So you should try like probably a couple dozen iterations, and then you'll see the topics evolve. And eventually, the topics will start making sense, hopefully. If they don't make sense, then you're going to have to do some more data cleaning. So this all seems very complex, but luckily, gensim does this whole part for you. So all you have to do is you have to say how many topics you want, how many iterations you want to go through, and do the interpretation. So our input is our document term matrix, our number of topics, and our number of iterations. Gensim will find those probability distributions that are best. And then the output is you'll see for every topic, what are the top words in that topic? And then you have to figure out, do these make sense or not? And so this here is probably one of the most famous implementations of topic modeling, latent Dirichlet allocation. It was created in 2003, paper by David Bly and also Andrew Ng, if you've heard of him from Coursera. So they all created this. So this is one way to do topic modeling, which is specific on text data. But you can also use general matrix factorization techniques. So those of you who know a little bit more about linear algebra, so that's basically you take a big matrix and you can decompose it into 2 or 3 matrices. And that's another way of finding topics, because you take, let's say, like a bunch of columns, and when you decompose it, you can squeeze that down into smaller columns, and those end up being your topics. So those techniques are called LSI, which is essentially singular value decomposition for text. You know what that is? And then NMF, which is non-negative matrix factorization. Those are also included in gensim. So you can use that as well. But I think LDA is, I like how it's specific to text, so that's the one I like to teach. OK, so let's run through topic modeling in the Jupyter Notebook. OK, so with topic modeling, you'll see that this is absolutely an iterative process. So I have attempt 1, 2, and 3 here, because my topics don't make sense. It takes a long time to try to make them make sense. So what I'm going to do here is first I'm going to import the document term matrix, because again, order doesn't matter. So because we're working with this bag of words model. And then all of this here, like these 3 cells here, these are specific to using gensim. So I'm going to import some modules from gensim. I'm also going to import, so I've commented this out for now, you can also import logging. So logging will help you debug. So when you create a topic model, it will log what's happening at every step. And you can actually look at the hyperparameters and tune them some more. So that's for you to look at later. And then at this point, for these 2 cells, what I'm doing, oops, let me run this again. So for these couple of cells here, what I'm doing is preparing for LDA. So here, the first thing I have to do is, for LDA, it actually requires a term document matrix. So instead of the document term matrix we're going to be using, we've been working with, it's transposed. So I've transposed it to a term document matrix. And specifically for LDA, you have to convert it into a sparse matrix first, and then into a specific gensim corpus. So a sparse matrix is basically, so here we have this matrix with a lot of zeros. It's not the most efficient way to store that matrix. What a sparse matrix will do is saying, for this row, this column, there's a value in there, and here's the value. So it stores it in that format. And then that's just the format that gensim reads it in. And then gensim also requires a dictionary of every single term and their location in that document term matrix. And you can get that from the count vectorizer. So if you remember our count vectorizer, it was a big document term matrix. It has this vocabulary items thing in it that has for every single column, what's the ID for that column. It's just something that LDA requires. So at this point, so we've done all the setup. This is actually where we're running LDA. So LDA here, you can see it requires 4 things as input. So the first is our corpus, which is in this case, it's actually our term document matrix, but they call it a corpus. ID to word, which is our dictionary of, for this term, where's its location in that term document matrix. Our number of topics, which will start at 2. And then our number of passes, which will start at 10. And the reason I'm starting at 10 is 10 is actually not that many passes to make all those updates. But just for this tutorial, I want to make sure we have some time to run through all this. So if you run those 3, it's going to take a while because it's going through every single term in your entire corpus and making those updates. So at the end of the day, this is what's happening. So you see, these are the 2 topics that emerged. So for this first topic, these are all the words there. And the second topic, you see here. Anything interesting from this?
Yeah, you got some cross-stemming going on there. First term and first topic matches a stem version.
Yeah, absolutely. So you start to see those overlaps in those topics. So when I look at this, I don't find this super meaningful. And so at this point, I did a lot of work to try to figure out how to make this better. The first thing I always do is I try to increase the number of topics, but that didn't help me too much. I saw so much, so much overlap between the topics, and I was like, oh, I wish I could do better. So the second thing I did was I looked at nouns only. And so this is a very popular trick that you can use. And
Sorry, it seems like the LDA would have that weighted up pretty high already.
which one? Oh, for nouns?
Yeah. Obviously,
It doesn't specifically weight nouns.
Okay.
Yeah, it doesn't do that automatically because it looks at all the words the same. But yeah, so it's very,
Because it's intuitive, I think nouns are very
yeah,
key indicators of topics.
yeah.
Like when you're doing pets and foods, right? Like basically, it's you're scoring nouns.
Yeah, which is why we filter by them. So it's like the easy, clean way to do exactly what you're saying, like look at the topics by nouns. So the way I'm doing that here is from NLTK, I'm going to import this parts of speech tag. And what I'm going to do is for my text, I'm only going to look at nouns. And the way I know that nouns is NN is because UPenn has created, their linguists have created this tag, all these tags. So you see there's a lot of manual work here. Like when I took my first text analytics class, that's when I learned that it's not all magic. It's a ton of manual work. People have spent a lot of time labeling this stuff. So let's do this just for nouns. So at this point, I'm going to run through this because we're running a little bit low on time. But you'll see here that once I filter out all the nouns, or I filter it so it's just the nouns, some of these words are a bit more meaningful. And so if I scroll down here, you'll see these topics are a little bit more about nouns. They're getting a little bit more meaningful there. Yep?
I tried working with spaCy library for a lot of speech tagging.
I have, but I will talk a little bit about spaCy at the end. But you can absolutely use spaCy for that as well.
I also use that I found that it works better with a lot of speech tagging than
I could see that, because spaCy is like the newer version of NLTK, and it can do a lot of the same things, but better and faster. So,
And I know we're going time.
Sure.
In the second topic, you've got he's, as.
that's probably he's because we removed the apostrophe.
Yeah,
So,
but how's that a noun?
oh. Yeah, I guess they've tagged it.
It's a pronoun, that's great.
Yeah, they've tagged it as a noun.
I don't see it clearing up yet. Maybe you see patterns in there. I don't. But
No, I don't really see it clearing up either. So I didn't see it really clearing up either. So the next thing I did, my attempt 3, was including nouns and adjectives. It's like not just about nouns, but like how do people feel about those nouns? So at this point, I've included nouns, NNs, and JJs. Again, I know that because it's from the UPenn tag set. And then I ran through this a couple times, and this was starting to make a little bit more sense to me. But at this point, I'd spent like a day on this, and I'm like, I think this is the best I'm going to get within a day. So at this point, I decided, OK, out of all my topic models, I think nouns and adjectives work pretty well. And I settled on 4 topics because it was as good as I could get for that day. And so my final LDA model, what I did was I ran my topic model for 4 topics, and I ran it for a lot of iterations. And the reason for that is so that it could reach that steady state over time, and it can get more fine-tuned topics. So what I like to do is try a lot of things for a few iterations, and then once I zone in on the best one, I'll do that one for a lot of iterations. Do you have another question?
Well, I just want to see what 4 topics you ended up with.
Yeah, these are the 4 topics I ended.
Parent jokes or family jokes.
Yeah, so like the first one was like talking about mom and parents. Second one was talking about husbands and wives. This one was talking about guns, and then this one just a lot of profanity. And so those are the topics that I ended up with. Definitely could be better, but a first pass.
It seems like you have almost better sort of assigning topics, because I think intuitively you can figure out what comedians make jokes about.
Yeah, absolutely.
And then figuring out like how to reverse your LDA algorithm to like start matching what you already have a sense of.
Yeah, you can absolutely like just tag things with topics as well. So this you find useful when you have really large documents that you have like no idea what they're about, and then this can pull out topics.
So using it as supervised instead of unsupervised.
So
Tag,
LDA you would always do as unsupervised. Or if you know what the topics are, you can go the supervised route and say you already know what these topics are, and so then you can just see like what words are tend to be part of that topic.
Using LDA or using
Not using LDA, yeah. So all the topic modeling techniques are unsupervised, including matrix factorization. It's all unsupervised. Yep.
I'm not sure how many people are experiencing the error, but it just can't find something related to punctuation. It's like
Oh, I've seen that. So within the error message, it says you have to download something or import something. Just add that import to the line above it. So I think there were 2 that you had to go through. So there's 2. There's only 2. So you've imported NLTK, but there's a lot more that you have to. NLTK has a ton of stuff in it, and there's more you have to download. Yeah, you have to do that 2 times in the cell before, and then it should work. Oops. OK, so yep.
One real quick
Yeah.
clarification. So gensim did the compression from like apple banana into food. Is that part of it? Or?
So yes, gensim was able to figure out this topic contains all these words, and then you have to figure out what those topics are.
Yeah, the first time you had it just looked like words, but then later on it started to do it with compression.
So it's always, I wouldn't think about it as much as a compression as like a mix of words or a probability distribution. So it's like figuring out what the most common words are in that probability distribution, and then it's like doing a better job of curating that list.
But then where would the word food come from?
So the food, that doesn't come from gensim. You have to label it as food. Yeah. OK, so at the end of the day, the other thing you can do is now that you've come up with the topics, for every comedian, you can see what topic they talk about. And so it just ended up happening that every comedian only had 1 topic they were assigned to. But a comedian can actually, one document, so one comedian, can actually contain multiple topics. But in this case, every comedian is assigned 1 topic, and you see that Ali Wong is part of that second group that talks about husbands and wives, along with Mike Birbiglia and John Mulaney. All right.
Even though the topics were pretty rough, you still got that same parity. Those three clustered together.
Yeah, which is pretty amazing with just like a short amount of time for this analysis. Okay, so we have about 7 minutes left. And I'm not going to go through this one in detail, but I think it's pretty cool. So text generation, your input into this is a corpus. So order matters, right? Because you're trying to figure out what the next word is. And there's nothing special in Python that we're going to do here for text generation. But the output would be a new comedy routine. So this is purely for fun. And the way you can do this is using something called Markov chains. So Markov chains are basically a way of showing how states change over time. So the main assumption of Markov chains is that the next state of a process only depends on its previous state. So instead of going through this example, I will just go through the text example. So with the text example, how it works is it takes every word as a state, and then it looks at the next word, and it says, how likely is this going to be the next word based on this word? And then for this word, how likely is this going to be the next word based on this word? And then you can see it can even wrap around. Like if this is a word, there's a 10% chance that this is going to be the next word. So the idea of Markov chains is the next state is only based on the current state. So within Python, you can make this a dictionary. And you can just say the keys are the current words, and then the values are a list of the next words. So it's a very easy way for text generation. Seems like a pretty simple model. It is. And you end up with some really funny comedy routines at the end. So I'll let you discover that on your own in the notebook. But if you want to do this in a more complex way, then you would have to look at something like deep learning. So with Markov chains, you're only looking at the previous state. But with deep learning, you're also looking at not just a prior word, but words before that. And then with deep learning, it also predicts those words. And so it includes those predictions as well. So specifically for text generation, you would look at long short-term memory. OK, so we don't have time to go to that notebook, but I encourage you to look at it yourself. And then I want to summarize all this I won't ask you what you learned today. Sorry, we don't have time for discussion. But this is what you did learn today. You learned the data science workflow, how to complete this end-to-end project, all these things here, and then my motto. And you can see this is what we learned today here in this column. And then this is what you can go into next. So instead of just looking at a document TermMatrix, look into TF-IDF. It's the next thing to look at. So instead of word counts, it weights some of the rare words higher. And then these are other data visualization tools. We talked about classification techniques like naive Bayes and linear logistic regression, more topic modeling techniques, and then deep learning. And I also want to talk about the libraries. So we use a little bit of NLTK with the parts of speech tagging, but NLTK has a ton of built-in functionality. So parts of speech tagging, lemmatization, and so on. TextBlob is built on top of that. Makes it easy to use. gensim is for topic modeling. And you mentioned spaCy. So spaCy is like the next new thing. So a lot of my students are using spaCy now. But it's a lot faster than these other libraries. And I feel like it's going to replace NLTK one day. That's just my prediction. I don't know. OK. So to summarize, this was our question for today. What makes her routine stand out? And these were all the techniques that we used. And so now we can answer that question. What makes her routine stand out? So we saw that she talks about her husband. And I talk about my husband a lot in my lectures.
Not once this entire 2 hours.
I mentioned him once. Once. And then, but yeah, I have a lot of lectures on that. And then she has the highest S word to F word ratio, which I don't like the F word at all, but I don't mind the S word. So, and then she tends to be pretty positive and less opinionated, like me. So who are some other comedians I might like? So these people don't say the F word that often.
They say the S word a lot?
Mike Birbiglia doesn't at all. He says no swear words. These people have that similar sentiment flow. These people talk about similar topics. And you can see Mike Birbiglia comes up a lot. I just want to mention, I finished this analysis on Thursday, and then I got this text from my husband. As I was looking up a comic, I say, which one? And he says, Mike Birbiglia. And I was like, according to my analysis, he is most similar to Ali Wong. So my analysis worked. Yes?
Does Ali Wong know about this analysis?
No, but I should share it with her. That would be so funny.
So wait, so you like Ali Wong and your husband just randomly likes
Mike Birbiglia.
the one that...
Just randomly. I got that text 2 days ago. Amazing, right? So next steps. So try the text generation notebook. It's super cool. Apply this analysis to other comedians, and then also try this on your text data. Yep? Oh, interesting. Probably, because I don't think they're... Yeah, I'm thinking their recommendation engine probably doesn't actually look at transcripts. But.
They might use this to like figure out what kind of show to just next, what people like.
Yeah, absolutely. So I just wanted to finally give a shout out to my company Metis because they gave me time over the last 2 weeks to actually create all this. We are a data science training company, so we do live online trainings where you have a professor and a TA teaching you, and then we do in-person boot camps, which I'm teaching this fall, and quick trainings. And that's it. Thanks so much for coming.